Hey everybody, welcome back. Today we're going to be talking about lesson number 7. I'm going to go ahead and point out some of the highlights of the reading that you should know for a quiz and exam, and I'll also go over the lab assignment that is due this Wednesday. And for those of you wondering, yes, it was due tomorrow, but I decided to give you guys an extra day on it. So it'll be due on Wednesday. Alright, so let's go ahead and get into it. A break statement, as stated here, can cause a loop to terminate early. There's another type of way that you can interrupt the behavior of a loop, and that is with the continue statement, which causes it to stop executing from its current point where the continue keyword was found and then begin the next iteration of the loop. Now, also, it is worth noting this, that generally speaking, people don't like you to use break or continue commands inside of loops because they do change the way that their default behavior is. Or the loop could just be rewritten in a different way that you don't need them. But having said that, it's very common. Breaks are much more common than the continue statements. But in any case, just thought that that's worth mentioning. Okay, let's look at break in action. So down here we can see the keyword break after an if statement. So this looks like we're setting this up to loop 10 times, starting at 0 up to 9. And kind of unusual that they're actually doing the increment right here in the condition. That's odd. Normally you would increase it inside the body of the loop, like you've seen in previous examples, but in any case. So this is just going to simply print out the value of count starting at 0. Actually, it's going to start off at 1 because it's incrementing it here. So it's going to print off 1, 2, 3, 4. And then when it gets to 5, it's going to hit a break, which will cause that loop to terminate. So rather than printing out the numbers 1 through 9, it's only going to print out 1 through 5 and then stop. And just so we can see that, in action over here, I'm going to go ahead and copy and paste this code into our compiler. And you can see this when you do that, sometimes it'll mangle it. And I haven't shown you guys this yet, but a lot of compilers have a function like this beautify button, or every compiler has some form of automatic indentation. This one mostly works when I click on it, but I noticed that when I tried it for the first time a couple days ago that it has a couple odd things like putting the main after the int, or on the next line after int. That's unusual. You would normally have it here. It's also not correctly indenting this. This break statement, as we saw from the example, should be inside of here. In any case, let's go ahead and see how this works. So a break statement. Let's see, we get it printing out 1, 2, 3, 4, 5, and then instead of continuing 6, 7, 8, 9, the break statement forces the loop to terminate. All right. Let's go back to the book. Okay. And then the book gives you another example of a break statement being used here as an alternative method for quitting out of a menu system. All right. Okay. When a break statement is nested inside of a loop that is inside of a loop, it's worth noting that the break statement only affects the most the break statement only affects the for loop that it is inside of, or while loop or do while loop. So in other words, if I put a break here, it's not going to cause it to jump out of all of these loops. It's only going to terminate the loop that the break statement is inside of. All right, let's look at a continue statement. So down here, got another little simple loop. Looks like we're going to create a variable called test_val, initialize it to 0. Same thing, we're increasing it right here in the loop. And then here, we are going to test when it is 4. We'll hit a continue statement. So in other words, what will happen is when it is 4, it's never going to move down to here, because remember the continue causes it to immediately terminate this iteration of the loop and then restart itself. So we'll go back up here and start increasing test value and printing out. In other words, this is going to cause it to skip printing the number 4, because it will never do that cout statement on that iteration, but it will continue looping, unlike the break statement, to print out the other numbers that come after 4. So it'll print out 5, 6, 7, 8, 9. All right, let's go ahead and try this one. Oh, it didn't print the continue. I pasted the wrong one. Okay, well I can just modify this. Let's take this, and we'll make that be continue instead of break. And then put the cout statement down here. Okay, so let's see what we get this time around. Okay, so we get 1, 2, 3, 4, and then since we were checking to see if it was 5 when we did the continue, it skips 5, and then prints out the rest of the numbers up to 10. All right. All right, so there's your continue statement. Here's a fun example where you're renting DVDs, and it calculates the total charge for the rentals, and every third DVD that you rent is free. Giving away the age of the book here, right? DVD. All right. So down here, we just do a simple mod on the dev count. So if this mod 3 is equal to 0, that means it's the third one. And then we print out this message that this one is free, and then continue, because the code that comes down here next is to calculate the cost. So if it's a current release, it's one price. If it's a otherwise it's cheaper. Okay, but again, since the third DVD is free, the continue statement causes it to skip all the code down here where you're calculating the cost and not include that in the final balance. You can see here's an example. 1, 2, 3 is free, 4, 5, 6 is free, and so on and so forth. All right, and that's everything that you need to know for break and continue statements. So I'm going to go ahead and jump ahead to the next set of reading on functions. All right, functions. So a function allows you to break up your program so that if there's a common task, rather than repeating that, copying and pasting that code over and over throughout your main.cpp function, you can just write the code once and then call upon that function anytime you need that particular set of steps performed. All right, so how do we do that? How do we break up our code into separate pieces? This is just kind of trying to illustrate that this is a sequential program. This is one written using functions, breaking the code up into separate pieces. Okay, defining the function. So a function must have the following things. A function must have a return type, and that's just going to be any of the variable types that we've seen up to this point, like int or float or string, or in some cases the function may not return anything, in which case we'd return void. You have to give your function a name, and you need to follow the same rules that we use when we name variables, like you cannot start with a number. You can start with an underscore, you can start with a letter, you can put numbers, but they have to come after letters, so on and so forth. So all the same rules, and no special characters. So all the same rules for naming variables apply to functions as well. It's going to have a parameter list. That's going to go inside a set of parentheses, and that's just going to end up being a list of comma-separated variable declarations, but we'll see more on that later. And then finally the body, which is everything that's going to go between the curly braces, just like we've seen with while loops and if statements and things like that. Alright, so here it's mentioning void functions. So it's very common to have a function that does something like this right here. All it's going to do is display a message. So if all it's doing is displaying a message, it's not going to return any value. It's not going to return the product of some type of arithmetic formula. All that's happening is it's printing out a message. So in that case, the return type for this function would be void. So how do you actually call a function? All right, so we got our main function down here. Notice that up above we have our function definition. And we'll talk more about why you don't want to do this later on when we talk about function prototypes. But anyways, we got our function defined up here. Again, return type, name. The name is going to be display message, and then a parameter list here, which happens to be empty. And then how do we call this to make it print out this message? Well, all we need to do to call the function is put down the name of the function, followed by the open and close parentheses, and a semicolon. And that will do exactly what we see down here. So it's going to print out hello from main. It's going to hit the function call, and at this point this is where it does something that we have not seen in the class up to this point. It's going to jump all the way up here to where it was defined and execute this line of code next, and we can see that here. Hello from the function display message, hello from the function display message. And then once it finishes executing and hits the last closing curly brace of the function, it goes back down and continues wherever it left off. So it will go down and execute this third statement, which is back in function main again. So that's a simple example of defining a function and then calling the function and showing how the program will kind of bounce around a little bit. Before I get to that, I do want to go to here where they kind of show that behavior of how the program jumps around instead of just going from the top down to the bottom. You can see that once we hit display message, it jumps. Once it finishes, it comes back and picks up from where it left off. All right, the function header. Everything that appears before the function's body is referred to collectively as the function header. So the return type, the name of the function, and the parameter list are collectively referred to as the function header. All right, not to be confused with the function call, where we don't have to put the return type. All we do is put the name of the function in the parameter lists. All right. Okay. Here they're just showing that the function can be called multiple times, so they just put it inside of a for loop. You can see that it calls the function more than once. That's totally allowed. You can put a function call inside of anything. You can put a function call inside of an if statement, an else statement, a loop. Heck, you can even put it inside the condition of an if statement or a loop. So you can call functions from pretty much anywhere. Okay, you can have more than one function, obviously. So up here we're now declaring or defining, I should say, a function called first and another called second. And then down here we're going to call first. Again, jumps up, says I am now inside first. Then we call second, jumps up here and does this line of code. So nothing too fancy going on there, just more than one function. And again, here they're kind of showing you how the code jumps around. I'll let you guys trace through that on your own. You can also call a function from inside of another function. So here we have a function called deeper that just says I am now inside the function deeper, and then another function called deep which actually calls deeper. So you can do that. And you can do that as long as that function has already been defined somewhere above this function. So in other words, if I took all this code and I cut it and I pasted it above, it would not work because the function deeper had not yet been defined. So you can call a function from a function as long as it's already been defined. Okay, and here's a simple trace through. We're starting at main. We call deep, so it says I am now inside deep. Deep calls deeper, so it says I'm now inside deeper. It finishes, it comes back, and then resumes executing here, back in function main again. Back in function main again. All right, look at all that jumping around, right? Okay, so that is how you define a function and how you call a function. Let's talk about what a function prototype is. Now, it's uncommon to do what the book just showed us, where the definition came before the main function. Typically what you'll do is you'll put all your function definitions after the main function. But in order to actually call those functions from within main, we have to provide a function prototype. Now, all a function prototype is the function header for the function, followed by a semicolon. So when we put this above main, it allows main to know what that function does when you actually call it without having to know all the specific details of how the function is defined. And it's worth noting to you that the word prototype and the word function declaration are interchangeable. They're synonyms. They mean the same thing. So now we have another version of the first second, but this time we're using prototypes. So here Notice that we don't have the body, we put just the function header followed by the semicolon. And then down here after main is where we actually provide the specific definitions. And it does the exact same thing as it did earlier, so I won't trace through the code, but alright, so that's all that you got to do. So in order to call first, we have to have the prototype or declaration up here first. Now this is the way that it is most commonly done. The reason for that is that, remember with deep and deeper, we had to be specific about the order that we defined the functions in. By using function prototypes or declarations, it allows you to be able to define the functions in any order that you want. So you don't have to think about that when you're trying to debug, as, oh, should I define this function first, or should I put this one next? You don't have to worry about it. Once the prototypes are up here, you can put them in any order and it will still work because it knows what to expect. So that's why this is the better way to define and declare your functions. Okay. Now, up until now, we've only seen functions with empty parameter lists because all they did is print out a message. But if you want, you can provide data to the function when you call it by including whatever that variable type is in the function header, in the parameter list. So for example, there's in the CMath library, there's a POW function which simply takes whatever number is here and raises it to this power. So this is going to raise 2 to the 4th power, and then it's going to return that as an integer, and the value will get saved in this variable called result. Alright, here's another simple function that takes parameters. This one just takes one integer called num, and it's going to print out whatever the value of that variable is and doesn't return anything. So again, just a simple example of a function. So here, the difference is that instead of just having an empty list of, or an empty set of parentheses, now we actually include something in the function call, and that's referred to as an argument. So up in the declaration, it's referred to as the parameter list. Down here, when you're actually providing the values in the function call, that's referred to as the argument list. So we're providing the argument of 5 to our function call. And all this is going to do is print out the value is whatever they put, in this case 5. So I am passing 5 to display value, the value is 5. Now, it's worth noting that it's actually copying the value here in the call into this instance of the variable num. It's also worth noting that that variable only will live for the lifespan of the function call. So once the function finishes, the value of the contents of that variable become garbage. They're no longer usable. It's also worth noting that it's not actually modifying any original variables. So we don't have to use 5. We could also use a variable name there as well. We'll actually see an example of that in just a minute, I believe. Oh, it's also worth mentioning too, I didn't say this, when you use prototypes, instead of putting the function definition up here, notice that you don't need to provide the name for the variable. You only need to provide the type of the variable. Now you optionally can include the name of the variable, but you don't have to do that. Alright, so here we are just calling the function over and over and over with a bunch of different values. And then down here, they're just saying common error. When you call the function, you should not include the type. You just include the name of the variable, and that's it. Okay. Here's a function with 3 integers in its parameter list. So we have to pass it a corresponding set of 3 variables. So here you can see they're actually using the user's input here. So here they declared 3 variables. The user read in the information, and then instead of passing a literal, you're passing the name of the variable. And again, when you do this, you're not overriding the values here. It's passing a copy of this value into these variables. So these now get a new copied value from this, prints them out. And if we did modify num1, num2, num3 here inside the function, again, it would not change the value of these variables. And they call that pass by value versus pass by reference, but we'll talk about pass by reference in the next lesson. Let's see. And then this is what I said. Like all variables, parameters have scope, and the scope of the function, or the scope of the variable in the parameter list, is the lifespan of the function call. Okay, this is saying what I already said, that when you call the function, that you're just passing a copy of the value. It doesn't get modified, and then here they're actually demonstrating that. So here is a variable called number. It's set to 12. We print out the value of number. We have a function called change_me, which is passed an integer. And then we can see that change_me resets the value to 0. And then it prints out that value. So it'll print out 0 here. But when we come back after the function call and resume here, and remember, number was set to 12. Here we passed it by value. That doesn't modify the value, so we should print out a 12 again. And that's what we see happening here in this line. So once we come back to main, the value has not been modified, even though the function modified the value. Now again, we'll see later that we can change that behavior and we can make it so that it would be equal to 0, but that's passed by reference, and we'll talk about that later. Okay, we're almost done here. Another menu program. And the idea behind this one was we're using this show menu function to simplify the code. And then we have another function that just simply prints out the fees. Okay. I think, was there anything else for this? Ah, yeah, the return statement. So we've seen a lot of examples of programs or functions that return void so far. But if a function actually returns a value, like an integer or a float, then we need to use a return statement to get that value to get sent back. Now, here's a simple example. Okay, oh no, this is kind of weird. Yeah, so here this is an example where they're checking for division by 0, because you can't have a 0 in the bottom of a division statement. So in other words, that can't be 0 when you go to attempt to divide. It won't let you do that. So here they're just checking in this that if the argument that they passed to be divided is 0, then you use a return statement so that you never try to do this division illegally. So that's kind of I shouldn't say uncommon way, but most of the time when you use a return statement, like I said, you're returning a value. So let's see, where's one more? There we go, returning a value from a function. Okay, so we can see that when we call a function, it may get multiple arguments, but it only returns a single value, just like functions in math in the same way. Now, there are ways to make it so a function effectively returns more than one value, but again, we'll talk more about that later when we talk about reference variables. Okay, come on, book, show an example. All right, so here we go. All right, so here's a really simple function called sum, where the user passes it 2 numbers, and it calculates the sum, assigns it to a variable called result, and then return result will return that value back to wherever it was called from in the original call, whether it's a function or from main. Now, it doesn't have to be a single variable. As you see, they point out that it can be an entire expression. Like down here, we got the whole expression num1 plus num2. So it's going to do this calculation first and then return that result. So this is just a simplified version of the same function that we saw up here. Instead of doing it and putting it in one variable, we can just straight up do the addition and return it. Okay. So here we got value 1, value 2 in total. Total is going to be set when the sum is called, and then the value is returned from that function like we saw earlier. All right. And then there's one more example that the book gives on using multiple functions to calculate the radius of a circle, which I'll leave to you guys to read. Okay, so I'm going to go ahead and switch over to the lab because there's quite a bit going on in the lab. So we are going to take that out, switch over to here. Okay, you are going to rewrite your work from lesson number 6. So if you didn't do lesson number 6, then you're already kind of behind the 8 ball here. But we're going to rewrite the Math Tutor program that we did from the last lesson, and we're going to add a couple little tricks to it. Number one is we're going to let the user now define what the range of the numbers are when it's generating a problem. So for example, if the user chooses to do addition, we say what is the low number and what is the high number. So what is the range of numbers that you want the problem to use? So you're going to use a function to do that, to get those random numbers. 8 and 14 were the two that came out in this case, and then same functionality in terms of when the user answers, that you either tell them that it was correct, or if they got it incorrect, you tell them what the correct answer was. Okay, down here we're calling it again, asking the user for what the low number is, asking the user for what the high number is. We randomly got back these two. 23 minus 22 is 1, so that's correct. And 3 to quit. Alright, so let's take a look at the code. So I do want you to use prototypes. Don't put the definitions above. And we're going to have two functions. We're going to have one function called random num and another function called ask question. Because these are generating random numbers, you need to make sure to include the time, the C standard library, and see the function. Okay, next, we have the same do while loop that we had in the last solution. Now, a common mistake I saw on the homework that was turned in was people would print the menu here and not here inside the body of the loop, and it's because I think what's happening is people were taking this literal. Whenever you see a comment above a control structure like a loop, that statement is just sort of summarizing what that whole loop is doing. So it's just telling you that this is going to print the main menu at least once here, but loop as many times as the user wants to, while the choice is not equal to 3 to quit. So this is describing the whole loop. It's not literally telling you to put to print the menu right here. You print the menu right here, so that way it prints every time. Okay, you get the user choice, validate the choice using the input. Most people look like they got that correct using the while loop and the or logic conditional operator, so that's all the same as the last program. Here's where things get different. Here, instead of having an if-else-if with a bunch of logic embedded into it for calculating whether you should add or subtract or whether they got it right or wrong, you're going to embed that all into a single function, the one that I mentioned up here called ask question. So the user at this point is just going to look to see if the person chose 1 or 2, and then based on what they chose, they're going to call ask question. So here, I'm going to get ask. This is all going to need to be replaced by you with the function definition. So let's start with ask question. So the return type for ask question, I believe, is going to be nothing. So it's going to be void ask question parentheses, and then 2 integers, which represent the choice that the user chose from the menu. Okay, ask the user for the range of numbers. This is where we're asking for low and high. And then call your random number function. So random number function is your other function. And you're going to use that same high-low mod with a rand number plus 1 plus min calculation that we used in the previous 2 lessons. So if the person chose addition, calculate the correct answer to the problem using addition. Otherwise, use subtraction to calculate the correct problem. And then ask the user for their answer. And then when you're asking the question, use the variable that they passed in to either print a plus symbol or a minus symbol. And then finally, if the user got it right, do one thing. If they got it wrong, tell them they got it wrong. Tell them what the right answer is. Okay, so hopefully you guys were able to figure that out on your own. Just so you can see, just a quick example of where am I? Writing a function. I'll give you guys some help. So let's start with the random number one. So for random, it's going to return an integer, and the name of it is random number, and it takes 2 integers. And because it's a declaration, we've got to put a semicolon at the end of it. Next, I'm going to go ahead and just copy the header, because we're going to need to use the header in the definition. Paste that here, and put my open and closing parentheses. Now, we know that this does not have to have a name. We could do it if we wanted to, but down here we do need to have a name. So this is going to represent the low number in the range and the high number in the range. And again, we're just returning a random number between low and high. So we can just put a return statement, and we're going to return and use that equation that I gave you guys in class. And we're going to mod that with the high minus the low plus 1. Okay, and I group that so that it performs the arithmetic in the right order. And then remember that whole thing needs to be offset by the low. Okay, and then I'm just going to wrap that whole thing in parentheses. Alright, that's it. That's your function definition for the random number. So up here, we can go ahead and just get a couple value, the low and high from the user. The high value. And then just to see if the function works or not, we can go ahead and just call it once. Alright. Let's test out our function call. So and then here we're going to pass the user low, user high. Okay, and it's just going to print out a random number to the console. So we'll just do that. Alright. So we're just going to get the low from the user, the high from the user, and then print out a random number between that range. We're just testing out to see that our function actually works. And I got all kinds of errors. Okay, let's see. And where am I? Low is not declared in the scope. Oh, user low. User low. User high. Alright, let's see what else. Yeah, okay. Okay. Just return an integer, should be okay with that. Random returns an int. Why is that like that? What am I missing? Should just print out the function call, the result of this. Oh, this is where I wish you guys were in class and you go, yeah, you're missing a semicolon right over there. Or you named that the wrong thing. Well, I'm going to pause here. Okay, I see where I did something wrong. I didn't put an L here. And L. So let's try running this again. This is a good place to point out this is not the greatest compiler in the world. If I was using Visual Studio, I would have got the red squiggly line right there, and it would have been a lot easier for me to figure out where the heck the problem was. But that was why it was not working, because I didn't put the L. All right, so what's the low number? Low number is 5. What's a high number? High number, let's do 12, and it randomly gave us back the number 10, which is between 5 and 12. So hopefully that helps you guys out with that random number function. There's the whole thing for you. And that is it for this video. I will talk to you again soon.